look at some topics out of section 4.3. We're going to talk about evaluating trig functions. And we're going to stick to only acute angles for this first set of notes, so just angles between 0 degrees and 90 degrees. So, and we're also going to be using only special angles. Now, what I mean by special angles is angles that are in the two triangles that we consider special, just because, well, they're special because they come up a lot in a lot of different problems and scenarios, and we can compute a lot of nice, interesting problems using them without using a calculator. So, the two triangles of interest are going to be the 30, 60, 90 triangle, and then the other one is the 45, 45, 90 triangle. Okay. Now, the side lengths of these triangles, well, there's an infinite number of 30, 60, 90 triangles. So the key thing here is that all of the sides of every 30, 60, 90 triangle are in the same ratio, so to speak. So I'm just going to consider kind of the simplest 30, 60, 90 that I can think of, which would have the sides of 1, 2, and root 3. The 1's across from 30, the root 3 is opposite 60, across from the 60, and the 2 is opposite the 90 degrees. And for the 45, 45, 90, the side values that I'm going to use most of the time are 1, 1, root 2. So again, I'm just picking a specific 30, 60, 90 and a specific 45, 45, 90. Those aren't the only two that exist, but those two have just particularly nice values. It just makes doing problems kind of work out nice when you use those two particular triangles. So when I'm talk about evaluating, what I mean is that we want to do the sine, the cosine, the tangent, cosecant, secant, cotangent of specific angles. So for example, if I said, well, what's the sine of 30 degrees? Well, we would have to draw a right triangle that has a 30-degree angle in it, and then we would have to compute the sine of that 30-degree angle, which is the opposite side length over the hypotenuse length. So I can just look at this triangle above, since I've already drawn it, find the 30-degree angle, find the side opposite, which is 1, and the hypotenuse, which is 2. So the sine of 30 degrees is 1/2. Now, be aware that we're going to be working mostly in radians this year. So we can also do this in radian measure as well. So if I said the sine of pi over 6, that's really the exact same question, because pi over 6 radians is equivalent to 30 degrees. So usually when I'm doing these problems myself, I'll have the 30, 60, 90, and 45, 45, 90 triangles drawn out on the top of my paper, like I do here on these notes. And then I'll think about, if I'm evaluating a trig function at a specific angle, I'll usually think about what it is mentally in degrees first, and then figure out what the answer is. So a lot of times I'll write the degree measurement just kind of like underneath the problem. And you might want to do that too, just until you get so good that you know that sine of pi over 6, that you know that pi over 6 is 30 degrees, just without even thinking about it. But it's a good practice to have in the beginning, I find. Okay. So then I would just find the sine of 30 degrees, which I've already done. That's just 1/2. So you figure out what angle you're looking for, find it in the particular special triangle, and then just evaluate the ratio, and that's going to depend on which of the six trig functions you're evaluating. So I'm just going to run through a bunch of examples here. So let's say we were doing the sine of pi over 3. Okay, pi over 3, that's 60 degrees. So I find the 60-degree angle, and I do opposite over hypotenuse. So opposite of 60 degrees is root 3. Hypotenuse is 2, so it's root 3 over 2. So when you're evaluating these, the input is always an angle. Keep that in mind. The input is always an angle, is always theta. And the output, what you're getting out of this, the answer you're writing down, is a ratio of sides. And the particular ratio that you pick depends on which of the 6 trig functions you're doing. So if I'm evaluating the sine of pi over 3, then my ratio of sides is going to be the opposite side divided by the hypotenuse. Okay, so let's try some more examples. What if I had the cosine of pi over 4? Pi over 4, that's 45 degrees. So I'm looking for the cosine of 45 degrees. So I find 45 degrees in my triangle. And so the answer is going to be a ratio of sides. It's going to be adjacent over the hypotenuse. The adjacent is 1. The hypotenuse is root 2. So the answer is 1 over root 2. Let's get in some of our other friends. How about the cotangent of pi over 4? What would that be? Well, again, pi over 4 is 45 degrees. Now, cotangent of an angle, that's, I got to think back to that last set of notes. Cotangent of an angle is adjacent over opposite. So if I'm looking at a 45 degree angle, adjacent 1, opposite 1. So cotan of pi over 4 is just 1. What about the cosecant of pi over 3? Okay, pi over 3, that's 60 degrees. So I'm looking for the cosecant of 60 degrees. So I find 60 degrees up here. Okay, there it is. Bam. And cosecant, that's going to be hypotenuse over opposite. So it's 2 over root 3. Now notice I could have answered that without even looking at the triangle because I figured out what the sine of pi over 3 is root 3 over 2. So if I wanted to find the cosecant of pi over 3, well, it would just be the multiplicative inverse of that, or the reciprocal of that, which is just 2 over root 3. Let's do one more. Let's do the secant of pi over 4. Pi over 4 is 45 degrees. Okay, so I'm looking at a 45 degree angle. Secant is hypotenuse over adjacent. So it's going to be looking at this 45 degree angle. Hypotenuse is root 2. Adjacent is 1. So the answer is root 2. So that's just a quick introduction of using the two special triangles to evaluate trig functions. So key idea is that the input is an angle and the output is a ratio of sides.